Hey guys, welcome. Yeah, so problem 5 of the AB 2018 FRQ, and part A just asks us to find the average rate of change of f on the interval 0 to pi, and the average rate of change is just the slope of the secant line. So on interval AB, for any function f, the average rate of change is just f of b minus f of a divided by b minus a. I've simplified a little bit here, but that's all there is to it. There's nothing terribly interesting about this part, so there it is, and we're done. Let's move on to part B. Part B says, what is the slope of the tangent line to the graph of f at x equals 3 pi over 2? So it's just asking us for f prime of 3 pi over 2, right? That's all it's saying, right? Okay, cool. First, let's find f prime. And since this is f, we have to use product rule to find f prime. And f prime of x is equal to, by the product rule, e to the x times cosine x, and then plus e to the x times negative sine x. And we can write it a bit simplified as e to the x times cosine x minus sine x, right? Okay, cool. Now, so then f prime of 3 pi over 2 is going to equal e to the 3 pi over 2 times cosine of 3 pi over 2, so cosine of 3 pi over 2, and then minus sine of 3 pi over 2. Okay, cool. So this is going to equal e to the 3 pi over 2, and then times cosine of 3 pi over 2. What is that? Cosine starts at 0, 1, goes down to 0 at pi over 2, and then to negative 1 at pi, and at 3 pi over 2 comes back to 0, so it's 0. And then minus sine of 3 pi over 2, on the other hand, is going to be, let's see, at pi, sine is 0, and so at 3 pi over 2, it's negative 1. So we have minus a negative 1, and so the minus 1 turns into a plus 1, so we just have e to the 3 pi over 2. That's the slope of the tangent line to the graph of f at x equals 3 pi over 2. Yeah? Okay, cool. So that answers part B, and now we can move on to part C. And part C says this. It says, find the absolute minimum value of f on the interval from 0 to 2 pi. Yeah? Okay, so what we need to do is compare values of f at 0, at 2 pi at the endpoints, and then we also need to compare these two to values of f at any places where f prime is equal to 0. So we need to figure out where f prime is equal to 0. So f prime is equal to 0 means we have e to the x cosine x minus e to the x sine x, which is what f prime equals, and so we need to set f prime right here equal to 0. And when we do, we know we can write e to the x cos x is equal to e to the x sine x, and because we know e to the x is never 0, we can now divide both sides of this equation by e to the x and cancel this, and so we have cosine x equals sine x. And so let me write that, cos x equals sine x. And then dividing both sides of this equation by cosine x, we can write that 1 is equal to sine x divided by cosine x. But we all know that sine x divided by cosine x is tan. So we're looking for tan x equals 1 on this interval. So that's got to be for x equals pi over 4. And then again, x equals 5 pi over 4, right? Okay, cool. All right, so then in addition to f of 0 and f of 2 pi, we need to find values of f of pi over 4, and then f of 5 pi over 4. And the smallest of these will be the absolute minimum value of f on the interval from 0 to 2 pi. Yeah, okay, cool. So first, what is f of 0? So f of 0 would equal, we got to go back to f now, not f prime. So f of 0 will equal e to the 0 times cosine of 0. Cosine of 0 is 1, e to the 0 is 1, so this is just 1. So this is 1. Okay, and then This is 1. And then now let's look at f of 2 pi. F of 2 pi would be e to the 2 pi times cosine of 2 pi. Cosine of 2 pi is equal to 1, and then e to the 2 pi is just e to the 2 pi, right? Without a calculator, we can't say more. So f of 2 pi looks like is equal to e to the 2 pi. Got it. And then next, we look at f of pi over 4. I wrote pi over 2 here, and hopefully you had faith that I was going to correct it. But yeah, it's pi over 4 right here, right? That's what we wrote for when tan equals 1. We said pi over 4 and 5 pi over 4. So f of pi over 4 will be f of pi over 4 will be e to the pi over 4 times cosine of pi over 4. Now this is a pretty hard number whose value is hard to estimate, but we know that cosine of pi over 4 is equal to root 2 over 2, so the best we can do here is write root 2 over 2, which is cosine of pi over 4 times e to the pi over 4. Okay, we don't really have too much of an idea of what this number looks like. I mean, I do a little bit, like root 2 is 1.41, so root 2 over 2 is about 0.7, blah, blah, blah. And we could similarly estimate pi over 4. But what is e to pi over 4, even if we knew that pi over 4 is roughly like 0.7 and change, right? Okay, anyway, let's just write it for now as root 2 over 2 times e to the pi over 4, and hopefully this will be easy to identify as being like smaller than all the others, because so far the 3 values are pretty hard to compare. Now, what is f of 5 pi over 4? F of 5 pi over 4 will be e to the 5 pi over 4 times cosine of 5 pi over 4. How lucky we are, because e to the 5 pi over 4 is just e to the 5 pi over 4, but cosine of 5 pi over 4 is negative root 2 over 2. And so we know that the value at 5 pi over 4 for f is a negative number, and none of the others are negative, so this has got to be the smallest. So this is negative root 2 over 2 times e to the 5 pi over 4. And so the absolute minimum value of f on this interval is this number right there, yeah? Okay, cool. So that's part C, and let's wrap up with part D, and that's when we need the graph here. Yeah, okay, so it says, let g be a differentiable function such that g of pi over 2 is 0. The graph of g prime is given right here. Okay, got it. And it says, find the value of the limit as x goes to pi over 2 of f of x divided by g of x. Well, let's try to evaluate the limit as is. So this limit, as it's written, is going to be f of pi over 2. I'm going to guess, no surprise, that we're going to get 0 over 0, right? Divided by g of pi over 2, which in fact gives us 0 over 0. Because f of pi over 2 will be e to the pi over 2 times cosine of pi over 2. The cosine of pi over 2 is 0, so we have e to the pi over 2 times 0, which is 0. So we have 0 divided by, and of course we know from the given that g of pi over 2 is 0, so we have 0 over 0. So what do? We do L'Hopital's rule, and L'Hopital's rule says that when we get a 0 over 0 when evaluating this quotient, then we could instead evaluate the limit as x goes to, I have a lot of videos on L'Hopital's rule, so check that out, but limit is, and I do much harder examples, but yeah, limit is x goes to pi over 2 of, we can look at the quotient f prime of x divided by g prime of x, and it's for g prime I suspect that we need the graph. Now, by our earlier calculation, f prime was equal to, so I have limit is x goes to pi over 2, f prime was equal to e to the x, and factored version, times cosine of x minus sine of x, right? And then now we have this divided by, and then the denominator is g prime of x, and we have the graph for that. Okay, so when we evaluate a pi over 2, right, so when we evaluate the limit, we get e to the pi over 2, and then times cosine of pi over 2, which we've already said is 0. So 0 minus sine of pi over 2 is 1. So 0 minus 1, right? Sine of pi over 2 is 1. And then that's the numerator. And the denominator will be clearly g prime of pi over 2. G prime of pi over 2. And g prime is the graph given. And at pi over 2, g prime is equal to 2, right? We could just read off the graph. So we know that the denominator here is 2. And what is the numerator? So the numerator is e to the pi over 2 times negative 1. So the denominator is 2. And the numerator is negative e to the pi over 2. And we are done with problem 5. Yeah? All right, cool. All right. I hope this was helpful, and keep watching. Take care.